Gauteng. Question number 1. Mufasa, the Lion King blockbuster premiered on 20th December in cinema across South Africa. Audience has the option to enjoy the movie in various formats, including 4D, X5, 4DX5, it's 4DX, it's supposed to be 4DX5. All right. Peter decided to watch the movie after the holiday rush had passed. Below is the plan of the 4DX5 cinema in Emperor Paris, Gauteng. Choose, yeah, choose your seats. Time remaining 5 minutes, 26 minutes. Then Musa, the title of the movie, then Emperor Paris, 4DX, then Tuesday 7th at 5. All right, let's continue. We shall use, this is the sitting plan or the cinema hall. Identify the type of plan provided. We shall say it's called a sitting plan. Okay, write down the date and the time that Peter went to the cinema. We've just seen it here. We've just seen it up here. It says Tuesday the 7th January at 5. So we shall come back there and say Tuesday 7th January. Then the set time. Okay. So using the online booking system, will Peter be able to reserve seat E7? Write yes or no and explain your answer. Let's look at seat 7. Seat 7 that we're looking at, it's already this one here. And when you look at it nicely, it's already taken, it's shaded. So we shall say no. It is already what? It's already taken up. Okay, here we go. Determine the probability of Peter successfully booking a seat in row D. Express your answer as a fraction by choosing the correct option below. So we are coming here, we say D. In D, places that are taken, we have 1, 2, 3, 4. 4 out of how many? Out of 12. So what's that probability? It will be, whatever is remaining is 8 out of 12. And I believe the answer there will be C. 8 out of 12. Successfully. The probability of, so because 4 seats are taken in that row. So what's remaining? It's 8 out of 12. Okay. 1.5. Determine the total number of available seats in the cinema hall. Now, what we're going to do, available seats. So what we are going to do to count all the number of seats in the cinema hall. So from here coming down, this is 1, 2, 3, 4, 5, 6, 7. That means 7 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 7 by 12. That's the first thing you're going to do. So all in all, 7 by 12, you end up having 84 seats. But of the 84, these 3 are not occupied there. So we say minus 3, remain with 81. Now of 81, how many are occupied? Because the question asks us available. seats. And available seats are the ones that are still blank. All right? X means not available. So what we're going to do, we shall come there and say, we've already calculated, so we have 81 seats all in all, but minus the ones that are already taken. How many are taken? We shall say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we come here and subtract 19. So available seats will be 81 minus 19, and I believe you remain with, is it 61, 62? 81 minus, so remain with 62. 62 available seats. 62 available seats. So we are saying total seats minus not available, then minus the booked ones. So whatever remains, it's available. So we say the total seats, we said they're 84. We took off the not available, which were 3, then minus the 19, which are already taken, and remained with the answer as 62 seats. Question number 1.2. Here we go. We have a diagram like this one here. Peter visited his cousin in Perth, which is in Australia, during the December holidays in 2024. He booked a return flight from Perth to Johannesburg. When it is 24/7 in Johannesburg, it is 13:24 in Perth. They're asking us, we shall answer some questions there. Says, send the information above and answer the questions that follow. Determine the time difference between Perth and Johannesburg. Remember they said, so we shall take this 10 here minus this 10 here. So the difference time, so it's 13:24 minus 7:24. And this could be 6 hours. These are 6 hours. 6 hours. Identify the flight number for the flight that Peter booked from Perth to Johannesburg. From Perth to Johannesburg. Look at this. Perth to Johannesburg. 2. So the flight number will be this one. SA 281. SA 281. The departure time of the plane from Perth to Johannesburg was indicated as 8 a.m. on the map. Indicate whether this time is written in 12-hour system or 24-hour system. Let's look at that. It's here. The moment you see this AM, just know it's what? Analog, which is the 12-hour system. AM, so we shall say here, it's 12-hour what? System. Another name for this 12-hour system, we shall say it's analog system. Analog system. Analog system. 1.2.4. If the flight departs from Perth at 2, which is 14 hours in South African time, determine its arrival time in Johannesburg. Express your answer in 24-hour system. Now, meaning it's going to leave at 2. Let's say the duration they're telling us it's 11 hours and 15 minutes. So we shall say, come here, add 15. All right. Now, when you look at this critically, it's going to give you 25, 15. But we don't have 25 in 24-hour system. So what do? We subtract the 24 hours, giving you 115. 115. 115. All right, they're telling us in 1.2.5, select the correct calculation from the options below. When you convert the total distance between Perth and Johannesburg from miles to kilometers, round off to the nearest 10 kilometers. In other words, you're changing miles to kilometers. Okay, we shall look at the scenario that we have here. This is it. The distance they're telling us is 5,193 miles. And when you look at this nicely, it's already given to you. So we are changing miles to kilometers. What are we going to do? So what we're going to do is to say, if 1 kilometer, allow me to use this place here. If 1 kilometer equals to 0.621 miles, what will it be if we have 5,193 miles? We want them to become kilometers. What's going to happen? We are going to cross multiply. So in that we remain with 0.621 unknown times the unknown equals to, in other words, I'm going to divide by 0, you see that? Which gives me, when I use my calculator nicely, it's 5,193 divided by 0.21. So the answer is 8362, 32. But they say to the nearest 10 kilometers. So we shall say 10 kilometers to the nearest 10 kilometers. So it becomes, sorry, not that, 60, not 20. Comes what? 60. So let's go to our options here and we see to the nearest. So it becomes A. All right, we continue to question number. We continue to question number 1.3. Oreo cookie mug cake, which requires only 2 ingredients, went viral in 2023. Refer to the pictures and the information below, which show steps for preparation or for preparing the Oreo cookie mug cake. Okay, this is what we have. A, B, C, D. Those are the images that have been given to us. These are the images. So now the questions come in. Convert the amount of milk needed for the recipe to milliliters, given that 1 cup is 250. So let's come to the ingredients. What do we need? A quarter of a cup of milk. So simply meaning, we shall come here and we shall say a quarter times 200 and what? 50. A quarter times 250. So we find out that we need 62.5 milliliters. Okay, that's what we need mainly. Select the correct option when calculating the cups of milk needed for 8 mug cakes. 8 mug cakes. So simple. What we're going to do is to get the one that we've got here. This is the only one that we need. So there's asking which option gives calculate the number of cups. So meaning we shall need to do this times 8. Times 8 times 8. So we get what? 500 mils. Then we divide this by 250. Why am I dividing? I'm looking for the number of cups of milk. So each cup is 250. So how many cups will I need here? I'll need 2. I'll need 2 cups. So my option here is what? C. We are looking for the number of cups, not milliliters. Write down the letter only. So the letter there is supposed to be C. Okay. We got 1.3.3. Identify the correct image from the information above and write down the corresponding letter for each step given below. E.g., step 1, if it's E, then you write E. So let's come here and you see step number 1 says place 4 Oreo cookies in a mug. So when you look at this nicely, oh, it's this one here, C. This is step number 1. 4 Oreo cookies, we have 1, 2, 3, 4. Then, that's step number 1. So step number 1 is a C. Pour a quarter of a cup over the crushed cookies. Pour a quarter of... So when in this image here, you see that this is the one it's pouring. Eh? So we say D. Then we have microwave for 1 minute. Microwave, definitely it's going to be B. So this is 1. This is 2. Then we have 3. So let's go back and write them. We say C, D, B. C, D, B. That's the order. So we shall say step 1, C. Step 2, D. Step 3, B. Other cookie companies also started the cookie in a mug trend. They are now Oreo, Dinner, Waffle, Hoho, then Suzy, type cookies available. Define the term probability in this context. Probability is a chance. One picks the mug available what? Compounds. Number 2, Friends is an American sitcom that aired from 1994 to 2004. The show revolves around 6 friends in their 20s who shared an apartment in Manhattan, New York. A floor plan of the apartment is shown below. Okay. The floor plan of the apartment is shown below. Okay. So they're asking us questions. Study the floor plan above and answer the questions that follow. What instrument can be used to determine the dimensions on the map? The dimensions are measurements. How do you measure distance on a map? Which instrument can you use? The best one is what? It's a ruler. And usually measure in millimeters. Determine the number of bedrooms shown on the floor plan. Shown on the floor plan. So we're going to count bedrooms now. We had 1, 2, 3, and 4, not any other. So we had 4 bedrooms. So come here, determine the number of bedrooms shown on the floor plan. We say 4 bedrooms. Okay, write down the total number of bathroom windows as a ratio to the total number of bedroom windows. Bathroom windows to bedroom what? Windows. So we have to go to the map and see. Bedroom we have 1, 2, 3, 4, 5. So those are bedroom windows. Bedroom windows. Having done that, okay, let's go to the bathroom. We only have 1, 2. These are for the bathrooms. So we shall count and say, we said 1, 2, 3, 4, 5. So meaning it's 2 versus 5, if not mistake. 2 versus 5. Two is to 5. It stops there. Okay. All right, then we go to another question that says 2.1.4. What is the general direction of bathroom A from B? You are in B. Look at that. From B, that means you're here and you'll be heading this side. So the general direction here, it has to be west. The western direction. Show with calculations that the ratio scale for this floor plan is 1 is to 3, is 1 is to 300. What shall we do? What we're going to use, it's what is given already here. It says 10 millimeters on the map is 3 meters in the apartment. This, the word meter, it shows you that this is real life. Why? You cannot measure a meter on a piece of paper, but you can measure millimeters. So we are proving. So they are telling us if you have 10 millimeters, you have 3 meters in real life. Guess what happens? The meter has to change into millimeters multiplied by 1,000. So leaving us with the 10 is to 3,000. Now they are both millimeters. What happens? I need to make this 1. So I divide through by 10. I divide through by 10. This goes with that, which is 1. I believe, which is this one here. Now, 30,000 divided by 10, this 0 will cancel with that. Becomes what? 300. So indeed, I've shown that the scale is 1:300. Hence, determine the total length of the apartment if measured length on the floor plan is 10 centimeters from left to right. We don't want to know whether left or right. All we want to do is to change this into real life. What are we going to do? 1:300. 1 unit on paper equals to 300. Now, for us, we have 10. What will they be? So simply meaning cross multiplication. So they will become 10 times 300, which gives me 3,000. But now these are centimeters. I want them to become meters. What do? I divide by 100. And the answer becomes 30 meters. 30 meters. 30 meters. 2.1.7. Write down the appropriate letter that makes the following statement true. The eastern and the western elevation walls are the boundaries for the eastern and western are boundaries for, let's go and look at this. These walls here, because this side is the west and the walls on the east, these ones. What are they boundaring? The 4 bedrooms, because I mean, this is a bedroom, also bedroom. Then another wall on the west. Here we have a living room. This wall here, and the bathroom. Still, this side you have a small what? A small wall. This one here. There's another one here. Probably this answer here was supposed to be 2 bathrooms and 2 bedrooms. Whereas we are saying 2 bedrooms. It would have been 4 bedrooms because 2 bedrooms, 1 living room, 1 bathroom. This answer, it's not that much clear, but the perfect answer could say 4 bedrooms because 2 on the west and 2 on the east. They are boundaries like this, as I showed you here. We have this bedroom here, another bedroom here. This is on the east. Then you have a bedroom here, another bedroom. How many are they? 4. All right, let's continue. 2.1.8. The land area of the apartment was built on has a length of 12.6 meters and a width of 8.4 meters. The the floor area of the apartment is approximately 60 meters squared. Determine the percentage of the land area that the apartment occupies. Round off your answer to find the nearest 5. So first and foremost, we shall find the area of the land. Area of the land, which is L times B. The reason why I'm using L times B because I have length and I have width, which is the same as what? W. Okay. Our length is 12, and the breadth is what? 8, 4. I believe, and I end up having the area of the land, it's 12.6 times 8, 4, which is 105.4 meters what? Square. That's the area of the land. Now, they're asking, determine the percentage of the land that the apartment occupies. So out of 105, it's 60% is taken. What will you do? You say 60 over 105.84 times 100. Why am I multiplying by 100? I'm looking for the percentage. So I will do that. I'll end up having my answer as it's 60 divided by times 100. So I have the answer as 56, 6 and 9. But they said round off to the nearest 5. Now, this is already what? Above 5. So, which makes it what? 60%. 60%. Okay. 2.2. Central Park is in New York City, close to the friend's apartment. There is a route indicated on the map for the walkers and runners. This map is shown below. Okay. The map is shown below. Let's see, and we go on and you see. This is how the map looks like. Okay, we shall continue. Okay, question number 1. Identify the type of map shown above. This is it's called a street map. The reason why we call it a street map because it has streets. Okay, name two bodies of water. Two bodies also. In other words, rivers and lakes. So when we look at the map, what do we see? When we look at it nicely, we have the lake there. And number 2, they said the Jacqueline Kennedy Reservoir. There's also this here. We can give that. There's also, we had one here, the pond, source of water. Then we have also, I think, the upper one here, but the ones that you can see, it's the lake and the reservoir. These two here. 1, the lake. 2, that is it. So there are 2 of them. Okay. Name the first street. Take note of that. Name the first street. Here we said the lake. And the what? The Central Park Jacqueline Kennedy Reservoir. This one here. Kennedy what? Reservoir. It's fine. Okay. Name the first street on the northern side of the Central Park. The first street on the so the north side is this one here. But the first street. So this is it, the northern part of the city. Because if it's like this, so this is the first street, né? W96 Street. 96th Street. Okay, 2.2.4. It says one of the friend's character, Joe, started cycling. His cycling speed is 13 kilometers per hour. The distance around the park is 6 miles. Calculate the time that it took. Calculate the time that it will take Joel to complete 1 lap around the park if 1 mile equals to 1,609 kilometers. Round off your final answer to the nearest minute. Now we are looking for time. What we have, take note, the speed that we have, 13 kilometers per hour. The distance is 6 miles. These two cannot marry. One has to change, one has to convert in that they become compatible. Now we shall change the mile. Why? It's easier because already speed is in kilometers per hour. So what we're going to do, we shall ask ourselves, if 1 mile is 1,609 kilometers, what about if we have 6 miles? What shall we do? We are going to multiply, which becomes 6 times 1,609 609 I'm changing my distance into kilometers because the speed I have, it's in kilometers. So here we have it as 9,65. These are what? Kilometers. I'm not interested in the kilometers. I'm interested in the time. So I'll say my time will equal to distance divided by speed, which will become 9,654 divided by 13. So I'll divide by 13. Indeed, I get my time, but this is in hours. These are hours. The final answer, nearest minute. So how do you change hours to minutes? We multiply by 60. So I have got 44,56, nearest minute. Simply meaning 45 what? Minutes. 45 minutes. Why did we change the distance to kilometers? Because the speed was already in kilometers per hour. Had it been in miles, we should just continue. But we had to change the distance because it would be easier to change the distance than the speed. Okay. That marks the question number 2, end of question number 2. Let's go to question number 3. Question number 3, it says what? During 2024 Olympic Games held in France, millions of people around the world turned in to watch athletics compete. So the host nation, France, added a unique touch to the Olympic and Paralympic medals by incorporating a piece of its iconic, the Eiffel Tower, into each medal. Each medal features an 18-gram central piece of wrought iron from the Eiffel Tower, symbolizing France's richest history and its connection to the games. Below is a diagram with various types of medals throughout the Olympic Games history. Okay, allow me pull up that diagram there. Okay, here we go. So the questions will be there down there, we shall see. 3.1.1. Define the term diameter in this context. Now guys, diameter is so simple. We shall say is you can say the straight line, through the center of the circle, or you can say diameter circle of what? Center of the circular what? Because not all circular, the circular medals. All right, the circumference of 1924 medals is 172.81 millimeters. Determine the difference. Take note of, determine the difference in centimeters between the circumference of 1924 medals and 2024 medals. So first and foremost, this circumference is already given to us, it's just like perimeter. So straightforward, we need to change it to centimeters. What we do, they're millimeters. millimeters to centimeters, we shall divide by 10. So the answer becomes centimeters. That's the circumference of the first one, which is 1924. Then we need to look for the circumference of 2024 model. It's not given. But then we shall need to use the so this is the one that's done. So we need to find this. We have the diameter as 85. So the diameter is 85 millimeter. Change this to centimeter. You end up having 8,5 centimeter. Then you're good to go to use the formula, which is pi d. So look for pi d, which is 3,142 times 8,5. 8,5, 3,142 times 8,5. We have the answer as 26,1. These are centimeters. Now, don't forget, we have this and we have this now. What are we looking for? The difference. So we need to come down and we subtract. We shall say, what are we subtracting? It's 71 minus 17, so 26 minus 17,28. So the answer or the difference is 9,43 centimeters. Centimeters. 3.1.3. The organizers of the Paris Olympic Games stated that the area of the medal of the 1924 medal and the area of the 1900 rectangular medal are equal when rounded off to the nearest whole number. Show by means of calculation that both areas are equal. Round off your answer to the nearest, look at that, to the nearest squared centimeter. The measurements that we have are in millimeters. The measurements we have are in millimeters. Remember, we are equating. That means you're going to find the area of the cylindrical and find the area of the rectangular one. So let's look at that. This is we shall start with the area of 1900. So 1900 is 59 millimeters by 41. So we shall come here. First and foremost, the 50 has to be divided by 10 times the 41 also divided by 10. Why am I dividing by 10? I need them to become centimeters. So simply meaning it's 5,9 times 4,1. Which becomes what? 24,19. These are centimeters what? Squared. Are we there? So we come back and we look at this. This now, this is the diameter. One side to another side through this circle. So we need the radius of this. But before we look for the radius, we shall need, so here, the 1924 medal, it has a diameter of 55 millimeters. Change that to centimeters, becomes 5, then divide it by 2 to look for the radius. So my radius will become 5,5 divided by 2. I have 2,75. These are centimeters. So simply meaning look for the area, which is pi r squared, which is 3,142 times 2,75. Don't forget, it has to be squared. 3,142 times 2,75 squared. The answer becomes 23,76. Remember, they told us to round it off to the nearest. So when you round off this to the nearest, it's what? 24 centimeters squared. Also, when you come to this, the answer becomes 24 centimeters what? Squared. What did they say? Show by means of calculations. Yeah. They didn't want you to verify. So that's why the answer stops. So indeed, they are both 24. We come to question number 3.1.4. The Olympic gold medal has a total weight of 529 grams. The medal is not entirely made of pure gold. The organizers used 6 grams of gold to plate its surface and incorporate the 18-gram piece of iron from the Elif Tower. The rest of the medal is made from silver. They claim that the medal consists of 95.5% silver. So what are we going to do? First and foremost, we shall come, get the total weight, minus, why am I minus? I'm looking for the weight of silver, because it's going to be the weight of silver over the total weight times what? 100. So I'm looking for silver, the weight of silver, which is going to be 529 minus 18 minus 6. They're all grams. So I believe I end up having 500 and what? And 5. 505. When you take because this is 529 minus 24. 500. So now this is the gram. So what happens next? We shall take, this is now the silver one, the weight of silver. So it's going to be 500 and divided by 529 times 100 divided by 5. Yeah, indeed, it's that 95.5%. So what are they saying? Verifying their claim. They claim that the medal is use calculation to verify their claim. Yeah. Their claim is what? The claim is valid. Then on the weight, because gold is heavier. Then number 2, to keep it cheap. To keep it cheap, to produce more what? More medals. To keep it cheap, to produce more medals. Because it has to be cheaper, ne? Okay, question number 3.6. 3.2. The 4 by 100-meter relay for both men and women always promises to be the highlight of each Olympic Games. South Africa has 4 phenomenal athletes qualify for the men's race. The USA introduced Shaya Sheikh as one of the outstanding women athletes and never fails to impress. There we go. Shaya was born to determine her age and maths. So guys, I'm here looking at this. The person was born in March. This is or the difference is 9,43 centimeters. Centimeters. 3.1.3. The organizers of the Paris Olympic Games stated that the area of the medal of the 1924 medal and the area of the 1900 rectangular medal are equal when rounded off to the nearest whole number. Show by means of calculation that both areas are equal. Round off your answer to the nearest, look at that, to the nearest squared centimeter. The measurements that we have are in millimeters. The measurements we have are in millimeters. Remember, we are equating. That means you're going to find the area of the cylindrical and find the area of the rectangular one. So let's look at that. This is we shall start with the area of 1900. So 1900 is 59 millimeters by 41. So we shall come here first and foremost. The 50 has to be divided by 10 times the 41 also divided by 10. Why am I dividing by 10? I need them to become centimeters. So simply meaning it's 5,9 times 4,1. Which becomes what? 24. This is the diameter. One side to another side through the circle. So we need the radius of this. But before we look for the radius, we shall need, so here, the 1924 medal, it has a diameter of 55 millimeters. Change that to centimeters, becomes 5, then divide it by 2 to look for the radius. So my radius will become 5,5 divided by 2. I have 2,75. These are centimeters. So simply meaning look for the area, which is pi r squared, which is 3,142 times 2,75. Don't forget, it has to be squared. 3,142 times 2,75 squared. The answer becomes 23,76. Remember, they told us to round it off to the nearest. So when you round off this to the nearest, it's what? 24 centimeters squared. Also, when you come to this, the answer becomes 24 centimeters squared. What did they say? Show by means of calculations. Yeah, they didn't want you to verify. So that's why the answer stops. So indeed, they are both 24. We come to question number 3.1.4. The Olympic gold medal has a total weight of 529 grams. The medal is not entirely made of pure gold. The organizers used 6 grams of gold to plate its surface and incorporate the 18-gram piece of iron from the Elif Tower. The rest of the get the total weight minus, why am I minus? I'm looking for the weight of silver because it's going to be the weight of silver over the total weight, 100. So I'm looking for silver, the weight of silver, which is going to be 529 minus 18 minus 6. They're all grams. So I believe I end up having 500 and what? And 5. 505 when you take because this is 529 minus 24. 500. So now this is the gram. So what happens next? We shall take, this is now the silver one, the weight of silver. So it's going to be 500 and divided by 529 times 100 divided by 5. Yeah, indeed, it's that 95.5%. So what are they saying? Verifying their claim. They claim that the middle is use calculation to verify their claim. Yeah, their claim is what? The claim is valid. The claim is valid. 30.1.5. Why did the organizers choose gold-plated and the gold medal instead of making it entirely out of gold? One, to cut down on the weight because gold is heavier. Then number two, to keep it cheap. To keep it cheap to produce more what? More medals. To keep it cheap to produce more medals. Because it has to be cheaper. Ne? Okay. Question number 3.6. 3.2. The 4x100 meter relay for both men and women always promises to be the highlight of each Olympic Games. South Africa has 4 phenomenal athletes qualify for the men's race. The USA introduced Shaya Sheikh as one of the outstanding women athletes and never fails to impress. There we go. Shaya was born to determine her age and maths. So guys, I'm here looking at this. The person was born in March. This is September. So the person's already what? 25 years. Then this is 25th. Exactly. 6 what? 6 months. So 25 years and 6 months. The 4 South African athletes each received a silver medal. Silver medals are made from pure silver. Show by means of calculation that their total weight is 2.02 kilograms. Remember, we got our difference of silver from the first example. We got the difference of silver as 505. These were grams. So if there are 4 of them multiplied by 2, what do you end up having? You have 2020. These are grams. What do we do? We divide by 1,000. In dividing, in so doing, what are we doing? We are converting this to kilograms because the answer we are verifying is in kilograms. Okay, so we shall end up having 2.02 kilograms by means of calculation to show that that's what we are supposed to do. All right. The 505, I got it from, it was question number what? Proving question number, we got it from here, silver. Three point 1.4. 3.1.4. Okay. We continue with this. The New York City Marathon is every year during the first weekend of November. The elevation map above sea level of the marathon is shown below in miles and kilometers. So they're asking us, which of the following best describes the elevation map? A, elevation map, height above sea level, meaning elevation map above sea level. This is what we are looking at. Okay. Identify the second highest point of New York City Marathon in meters. Second highest. This could be the one here. This is it, and we have this one here. Down, up, down, up. Second highest, let me see, 25. The second highest is this one. In meters. It's what? 15 meters. If you consider the 6-mile mark on the map and the 10-kilometer mark on the map, the 6 kilo mark is just short of the 10-kilometer mark. Show with calculations that the difference in the distance between the 6 and the 10, 6 miles and the 10-kilometer, rounded off to your answer to one decimal place, and show your final answer in meters. So what are we going to do? We are going to change the 6. We're going to change the 6 miles into kilometers. Why am I doing this? Because I want the final answer in meters. So if I have 6 miles, what will they be in kilometers? That means I need to divide by this. So here I get my 6 miles divided by 0.622. I have it as 9.6463. These are kilometers. What do? I multiply by 1,000. Why am I multiplying by 1,000? I need meters. The first one was miles to kilometers. So the second one is kilometers to meters. So I multiply this by 1,000 and I will end up having 9,646.3. But let me round off straight away. Okay. So this is the first one. Then the 10. For the 10 kilometers, this is going to be straightforward. The 10 kilometers, I just need to multiply by 1,000. And I get my 10 what? 1,000. Don't forget, we are looking at the difference. The difference in distance between. So what are we going to do? We are going to subtract. Minus to the nearest. So simply meaning so which became what? 354 meters. 354 meters. We go to question number 4.2. 4.2, it will need us to concentrate a little bit. It needs our concentration. Okay, let's look at that. Adam and John both entered the NYC, the New York City Marathon, and recorded the following information. A standard marathon is 26.2 miles on the imperial system, or 42.2 kilometers on the metric system. This is the information for these two people. One is in imperial, the other is in metric. Okay, define. This was supposed to be divide. This is what? Divide speed equals to distance divided by. Don't confuse that. We don't usually, we don't add actually. Okay, determine using calculations the finishing time for both Adam and John. assuming they maintained their average speed from 7:30 to 9:45. State which of the two athletes finished first. Now, how do we tell that? First and foremost, it's the person who spent less time is the one who finishes first. If anyone goes beyond the other person's time, that means the other one what? Was late. Okay, they are telling us, hint, you follow the steps below and guide in. And they're saying, you may follow the steps below as guidance in your calculations. Determine the average speed for both Adam and John from that time to that time. Then use the average speed for both Adam and John and the full marathon distance to calculate their finishing time. Their finishing time. State which two athletes finished first. Anyway, calculate their finishing time. Because speed, we shall need the speed to be in kilometers per hour. Meaning we shall change these miles to kilometers. Let's start with that. So distance for Adam will equal to 15 miles times. Now they have already given us up there. Oh, and do this. Okay. Let me find the comma because they said the standard marathon is miles. So if 26, let me see, 1 kilometer, 1 mile, okay. 26 miles equals to 46. What about 1 mile? So we divide through by 26 on both sides. 26 on both sides. So 1 mile equals to 42 divided by 26, 2. So 1 mile is 1,611, eh? Okay, 1. So we are looking at this. So now I'm going to use this to convert my, so I will come here and multiply by 1,611. What could that be? So simply meaning the distance covered here could be 24,16 kilometers. 24,16 kilometers. So what divided by what? By time. Now the time they have used, when you look at it critically, time used is almost the same as 15 minutes. 2 hours, 15 minutes. So, because we need everything to be in hours, we need everything to be in hours. What are we going to do? The 2 hours will become, I'm dividing this by this 6th. So 2 plus divided by 60. So the time used, it's 2,25 hours. So now our speed is easy to get. We shall say, this is Adam's, the distance we've got, we divide by the time, and Adams was running at 10 kilometers per hour. So for John, it would be so easy. Why? Everything is in metric and we also got the time. So we just need to look for the speed. 20 kilometers. So if John covered John covered a distance of 20. in the same time. At what speed was it? Uh-huh, 8,89 kilometers hour. So John covered 20. So, who was the fastest? This is Adam. Adam, because he covered a bigger distance in the same period, yet John was running. He covered a smaller distance in the same period of time. This you will take it to be, how is it called? A car that travels at 10 kilometers per hour is faster than the one that drives at 8 kilometers per hour. So Adam was the fastest. Okay, we look at that and we see 4.2. 4.2, we are saying Adam's girlfriend, Cindy, also wants to participate. Adam's girlfriend wants to participate. Adam's girlfriend wants to participate. And they're saying what? In the marathon the following year. She decided to measure her fitness and the BMI to get fit and healthy for the marathon. Cindy is 170 centimeters tall. 170 centimeters tall. And is unsure of her weight. However, the dietitian measured her BMI at 23.6 kilograms per meter squared. Okay, let's look at that. And says convert the temperature. This was straightforward. You had to just come, substitute this a temperature, put it where you see the F, 98.6 minus 32, open brackets. Please, there's a multiplication sign here. As you see, just put it in your calculator. Open brackets, 98.6 minus 32, close brackets, times 5/9, which is 37 kilometer, 37 degrees what? Celsius. Okay, so here we go. Determine Cindy's weight in kilograms. What do we have? We have the BMI given to us, the BMI of 23.6. This is already given to us. What else is given to us? We are given the height, which is 107. These are centimeters. But we cannot continue with it until it becomes meters. What do? We divide by 100. So the height has become 1,07 meters. Okay, we are good to go now. What's missing is the W. But when we look at this nicely, this is missing. But we have this and this. So if this is missing, which is the weight, it's going to be weight equals to the BM times the height, what? Squared. So our weight here is going to be, the weight is going to be weight equals to the 23.6 times our height. Sorry. Remember the height, they said the height was 170 centimeters. Yo. If it's 170 centimeters, meaning it's 1.7 meters. 1,7 meters. So the same, put it here, but square it. So put it in your calculator. 23,6 times 1,7 squared. So the weight will become 68,2 kilograms. Did they say anything to nearest? No. Leave it like that. Okay. Use Cindy's BMI regarding the class. Use Cindy's BMI reading. Use Cindy's BMI reading and classify her weight according to the table above. The table is this one here. This is it. Remember, her BM is here. Her BMI is that one there. Then it falls under this. What is the classification? We shall say it's what? Normal. It's normal what? Normal weight. Then hence advise Cindy on her health status and give one tip to follow in order to participate. Now, number one, advise on her status is what? We shall say keep eating healthy food and practice often. Practice often. This brings us to the end of question number 4. Let's start question number 5. Question number 5. Bullet Booty traveled to England to visit his cousin. While they secured tickets to attend Taylor Swift ERAS tour at Wembley Stadium. A layout of the stage platform where Taylor is said to perform is given below. The layout is just right there where Taylor performed, and there's a big screen behind there. 10 meters, that's the width of the stage, I believe. Then this is the runway to the smaller stage in front here. Okay, let's look at the questions that follow. Use the information above to answer the questions that follow. The screen used at Wembley Stadium, let's say it has a height of 110 feet. Convert the screen's height from feet to meters. So they already told you that you only have 1 foot. You have an equivalence of 0,3048 meters. So what we're going to do, we are converting 110 millimeters, 1 foot. So we are going to multiply. So 110 times 0,048, which became 33. These are meters. Okay, let's continue. A scaled model of the screen is built with a height of 0,5 meters. A scaled model. Taylor Swift is 1,7 meters tall. Calculate the required height of the scaled Taylor. Now, in other words, we are going to use the scale that's used. Now, they have already told you the convert the screen's height. It's this much. Yet it is scaled on 0,5. So meaning, if you have 3, in real life, on paper you have 0,5. So we are going to look for only 1. Okay, we can leave it like this. But then we are going to change. This is in real life. Yet this is on scale. So the scaled one. So we are going to change this. We're going to change this because these are meters. Anyway, let's continue and we see. So we shall multiply by 0.5 times 0.5 divided by 33.53. 33.53. So we have 1.75 times 0.5 divided by 0.7. Sorry. Divided by this other one here. It's divided by 0.5 divided by 3.53. So we divided as 33.53. So the answer will become 0.03 meters. In other words, we were reducing this to match the scale used for the screen. Okay, Taylor Swift covers the full length of the main stage and the full length of the runway once during a song. Calculate in meters the total distance she covers in one song. Let's look at that and we see. So it's going to be 10 plus 75. Why? From here up to the 75 and that much. So we are going to say it's 10 plus 75. The answer becomes 85. Don't forget the units. Okay. It is estimated that Taylor Swift covers approximately 3.91 kilometers during one show on the stage and the runway. Determine how many times she would cover each of the distance shown below. How many times? So this would be, first and foremost, these are meters. We shall change them. We shall change the kilometers. So we shall say 3.91 times 1,000. Times 1,000, which becomes 3,910. So now it's this that we're going to divide it by meters. So this answer gives us 37.23, which is approximately 38 times. Then what about a 400-meter athletics? Still, we shall come to this. divide by 400. Whereby we have 9.78. It becomes 10. We are looking at times. You can't say 1.5 times. So we have this much, half a marathon. Express your answer as a percentage. Half a marathon, express your answer as a percentage. This one here, it would be, can leave it because they're both in kilometers, but as a percentage now. What are we going to do? We shall say it's 18.533%, which is approximately what? 19%. Miss Buti lives in Pretoria and will be studying at Northwest University, which is situated in the city of Potchefstroom. So the map below shows various routes to travel from Pretoria to Potchefstroom. And I think this Pretoria is right here. And this is where the university is situated, the Northwest University. So we are using this dark line. Okay, let's continue. Okay. Identify the type of transport that Bullet Booty uses in your opinion. Explain why this mode of transport is suitable for a student. Uses a what? Shall we say a motorbike? It is faster than cars. Bullet travels on N1 and N12 Pretoria to Potchefstroom. Name 2 possible reasons why. 1, no traffic lights to stop and go. No traffic lights. And usually the speed limit is above. The speed limit is high. It's high enough, so they allow speeding up to 120. Name 2 incidences indicated on the map that might cause Bullet Blue to use alternative routes. Now, we have this first one here. High traffic volumes and accident. Those are the incidences that may make. So here you can say high traffic what? Volume and the accident. 5.2.4. Given that the time taken will be 3 hours and 3 minutes and the distance traveled is 177 kilometers, Bullet states that he travels approximately 60 kilometers per hour, rounded off to the nearest 10 kilometer. Verify showing Bullet. So first and foremost, time has to be, okay, we are verifying speed. So change speed equals to distance over time. Number 2, check that the time is in hours. So our time is going to be 3 hours plus the 3 minutes I have to change into hours. We divide by 60, which is 3 These are hours. So now we are good to go. The distance is already in kilometers. So what's remaining? To find our speed, which is divided by 3,05. So it's 58,03. They said to the nearest 10. Yeah, which gives you 60 kilometers per hour recorded. Let me verify, show you with it. Yeah. He is correct. 5.3, a map of Northwest University campus and portions is given below. If you drive in the westerly direction on Mayer Street, will Hoodstown be on your left? Westernly. I think they are saying westernly. It's so awkward. Okay, let me see. Westernly. Western. Now, this is north, this is west, this is east, and this is south. Now, if you move, like they're saying, because if you're moving westernly, you're heading this other side. And if you're heading this side, this is your right-hand side, and this is your left-hand side. So this one's supposed to be on your right-hand side, eh? Right? Right hand. Because now another thing is, had they said easternly, that means this would be your right and this is your left. If you're heading east. But the question says westernly, so they're heading that side. Provide two possible reasons why there are so many parking areas available on the. It's because what students have. Oh, yeah, students have private transport. Private transport. 5.3.3 bullet directed the friend Gunstone as follows from it's called the NWU Career Center. Let's first go and look for that. NWU Career Center. This is where the person is. So then they say go south, Steve Biko Street. Go south. South is this side. Steve Biko Street. You see that? Turn right onto Mayer Street. So you're coming like this. As you're coming like this is your right hand side and this is your left. So turn right, you turn like this. So they say, what else? Go across Hoffman Street. Go across, that means you come and cross through this. And they're telling you, remember, this is right and this is left. So they're telling you the destination will be on the left. What is it? The ladies' what? Hostel. This is supposed to be the ladies' what? Hostel, as we've seen it. The ladies, this one here. Ladies' hostel. And this brings us to the end of our question paper.